look at more of the chapter, I guess. And let's see, though. There was a question. No, there was just Samantha, Jasmine. Okay, everybody's in. Okay, so anyway, so that's how this next lab is going to go. You're going to be identifying by mineral content and by the crystal structure for igneous rocks. And so the igneous rocks will be separate from the other kind of rocks. So you just have to judge that small set of rocks. So it's not as bad as minerals, where you have 3 pages of rocks, of minerals. You just have 1 page of rocks, basically, for igneous rocks. Okay, so it's much easier. And don't forget to look at that sheet. Okay, so let's go see what happens later. Okay. This is just a cool graphic. It's not from your textbook, but I think. So anyway, it's just showing how much the color changes. So the felsic minerals are in general the quartz, the plagioclase feldspar, potassium feldspar, and the muscovite mica. And which it says is brown, but is whitish a lot, whitish brown. And then the darker minerals that make up the mafic, the biotite mica, which is black, the amphibole, which is a very dark gray, the pyroxene, which is a dark green, and the olivine, which is green. So yeah, so there is a big difference in the colors of the minerals. And so that's how they divide them up. Okay, we'll be looking at this Yellowstone stuff when we get to volcanoes. Let me do a picture of shiprock here. Okay, so the idea is that a lot of times the magma that's left is the granitic type. And then what happens is the softer parts of the volcano erode away, and you get left with, in this case, a neck. So this is in New Mexico. So Shiprock is a tiny little town down at the base of this gigantic rock that's supposed to look kind of like a ship, and that's why it's called Shiprock. So you can see it far across the desert. But it is just the neck of the volcano. So it's this small part down here. So you can see that the ground has eroded away till Shiprock is sticking up. Now, another feature here is called a dike. We'll be talking about that in a later part too. Devil's Tower of Wyoming. This is granite also. This is an old volcanic neck also. Okay, we're skipping stuff because we're going to do that later. Okay, now when we look at sediments, sedimentary rocks, this is something like the Grand Canyon. Okay, the Grand Canyon has all these layers of sedimentary rocks. We live in Illinois. We live on limestone. Limestone is a sedimentary rock. And so these were laid down layer after layer after layer from water bodies, usually. So you have, there were shallow seas around here. It's under the ocean. It's in lakes. All of those can create sedimentary rocks. Okay, so let's look at that. So about 75% of all rock outcrops on the continent are sedimentary rocks. So under the ocean, you mostly have basaltic rock, but on the continent, you have sedimentary rock. And it is very important. This is where the coal is. It's where the petroleum is. It's where we get a lot of our minerals. So iron, aluminum, potassium. So I was just watching a YouTube video about potassium. Very interesting. And so chalk and salt and building materials. We use a lot of these sedimentary rocks. And we also use them to look back in history because the sedimentary rocks have fossils in them because they were laid down in seas. And so you have dead fish and clams and things like that. Whereas you don't get fossils in um, the igneous rocks, because that was lava that came out, and there was no time for a fossil usually to get embedded in it, and usually they would burn up. So yeah. So if we want to know what happened in history, we have to look back in the sedimentary rocks. So that makes them important. Okay, so sediments can be rocks and mineral fragments. There's shells and shell fragments, and they're mineral precipitates. So we'll be talking about that stuff somewhat. And so yeah, so you can see that this can happen somewhat on land. And then you can see her slide. Your screen frozen. Okay. Okay. So let's see. I am presenting, I think. Okay. Okay, I can unpin this. I don't know if that will help, but she should be able to see the presentation. So anyway, all right. So anyway, so sedimentary rocks are made up of little tiny pieces that then get cemented together and compacted. Okay. And but we already did that one. Okay, so sedimentary rocks, there are two different groups. And one is detrital, which is the little pieces of stuff that we were just looking at. So detrital is the little broken shells and the little tiny pebbles. And then there's chemicals that also can produce sedimentary rocks. So limestone, a lot of that is a chemical rock in some ways. Okay, mostly detrital though. Okay, so let's see. So if I go back to my test one, back to content. Okay, and so where was I? I was in, let's go back to test one, review. And there's also the sedimentary rocks handout here. And so this is a long list, so has more rocks than we were just looking at in the igneous in some ways. And so what it's broken up into is detrital sedimentary rocks, and then chemical, biochemical, and organic sedimentary rocks. So that's where the limestone is coming in. So we've got different kinds of limestone. The ones with a lot of fossils is fossiliferous limestone. And that's biochemical limestone because there's lots of relics of animals in there and plants. Okay, so cemented with calcite cement. Okay, so we'll be talking about that more. But that's what the list is. You've got for sedimentary detrital and chemical, biochemical, and organic in the other list. Okay, so we'll be looking first probably mostly at the detrital ones. Okay, so for the detrital rocks, the material is all solid particles. They get classified by their particle size, and common rocks include shale, sandstone, and conglomerates, and limestone. Okay, so more samples coming your way. Oh no. The oh no is because I've got a lot of them buried in a box here. There's a piece of shale right there. Thing is how to, so I got rocks from Elgin Community College, went back and took a bunch of rocks. Okay, shale. Sorry, my shale is in there. I seem to have my shale in my slate. Or my shell has been so broken up, so it's good that I took some more samples. Okay, all right. So shale, sandstone, conglomerates, and limestone. Okay, get out the samples. So anyway, so detritus is broken into categories where there are boulders, cobbles, and pebbles. And so those are larger pieces. So pebbles, cobbles are like fist-sized, or an inch or two across. And boulders are things, of course, that would be pretty large. Okay, so like a foot. Okay, so anyway, so how big the samples are, that goes into the description. And then you've got sand, which is 1/16 to 2 millimeters in size. And then silt and clay are smaller than 1/16 of a millimeter. So very, very tiny, fine particles. And what happens is that you might have a cliff that's weathering away, and then those pieces can get brought down by a stream or by wind. And so they might fall into some water, and that's deposition. So weathering is where you're generating the detritus. Erosion is where it falls off, basically. So it removes from place. Okay, so it gets scraped off by the wind or by weather, cracks off, falls down. It gets transported by the wind, the water, and the ice. It gets deposited, so that's the accumulation. And then finally it gets lithification. So what happens is that there are rainwater filters through rocks, goes down through the cracks, starts dissolving out minerals. And so carbonate, calcium carbonate is one of the ones that dissolves out. And so we have a lot of that around here because we have limestone. So that white stuff that forms in your teapot or is in your bathtub, on the shower walls, it's all over the place here. That's the calcium carbonate that comes down, and that is what glues together the rocks. So it dissolves out and it glues together types of rocks, and so you makes new limestone out of it. Okay, so those ions of calcium travel down and then they lithify. So here you've got, so what happens is the detritus gets squashed, okay, gets compacted. As more and more layers go on top. And then there are the ions from the groundwater coming through, and they act like glue. Okay, so they cement it. So there's compaction, and compaction reduces what's called the pore space. So the pore space is the hollows in between the pebbles. And so things get compacted, and then they get glued together. So lithified, cemented. Okay, so that's what's going on to make a sedimentary rock. So it starts off not glued together, and then it gets glued together. Whoops, we already did that, didn't we? Yes, we did. We're down here, we're down here, we're down here. Okay, so again, you can rate it judged on its texture and its composition. So you look at what's called clast. Clast are the little pebble parts. And so you look at their size. And then you look at their composition. So was it a granite mountain that eroded away? Or was it a limestone mountain that eroded away? You'll get different types of clast, different composition. The other thing you look at is the angularity or the sphericity. So the idea is when you look at this rock, these pink pebbles are nicely rounded already, which means that they probably were carried along in a stream for a while before they became compacted. And also you look at things like sorting. Sorting is whether or not you have pebbles all the same size making it up, or if you have different sizes. So like this rock, they're not terribly well sorted. You've got some larger pebbles and some smaller pebbles. So you might say that this is not terribly well sorted. And you look at the character of the cement. What kind of material glued it together? And so that makes a variety of rocks. Okay, so size, composition, angularity, how well they're sorted, and the cement. Okay, so detrital rocks again. The boulder, cobble, pebble, pea gravel are small gravel. Coarse, medium, fine sand, coarse, medium, fine silt. We aren't going to be looking into this much, but this is how people would judge it. Okay, you can have coarse and fine clay. And the idea is that as water would carry the detritus around, the coarse ones drop out first, and the fine ones drop out when the water is almost still. So they get carried along by moving water, but then they'll get carried along and they'll land, and you'll get fine-grained materials that will eventually turn into clay. So if you've ever stepped off the bank of it into a stream or something, in some places your foot sinks in, and so what's going on there is you've stepped in some of this fine-grained material. So in the future, that might turn into shale, and your footprint could be recorded forever. Okay, so the sedimentary rocks that we're going to look at, the detrital ones, conglomerates, breccia, sandstone, arkose, which is a type of sandstone, siltstone, and shale or mudstone. Okay, so let's go look at these different ones. And so, conglomerates are made up of coarse gravel. You can see all the separate pieces here, and the particles have been rounded. Whereas its partner breccia has coarse gravel, but you can see how angular it is. These were broken off the cliff, and they never had time in a stream, or very little time, so they're not rounded. They don't have their edges knocked off. So that's the difference between these two, basically. So let's look at some conglomerates. Let's see. Okay, I'm going to go pin the picture again, hopefully. Where am I? There we go. Okay, so what you can see in this piece is you can see that there's a rounded pebble here and the rounded shape of one here. It's been broken off since then. And there's a large pebble here, which you can also see has a rounded shape. It's gotten broken off in taking the sample since then when they hit it with a hammer probably. But in general, the pebbles are rounded. But they are lots of different sizes. But you can see how rounded those are. Okay, so that would make this the conglomerate. Now, the breccia, this is going to be kind of hard to see. Let's see. So what you can see in there hopefully are some broken looking pieces. So like you can see the sharp edge there. And so this one doesn't show up too well. Okay. So anyway, but you can see here, this is a good patch where you can see some pieces that have sharp angles on them, that white piece there and the black piece. And so this would be the breccia, so the broken edges that never got a chance to become rounded pebbles. Not a great sample, but I think that's the only one I have. Okay. All right. So we got those two. Okay. And so I like the sample they have here is much better. And I think the one in your lab is pretty good. Okay. So sandstone. Sandstone is beautiful stuff. Comes in many different colors because of the many different kinds of sand that might have eroded out of a cliff or something. Oh, there it goes. And one of the cool things about sandstone is you can actually feel the sand. You can drop it off. So I've got a little pile of sand there starting. Okay, so just rubbing it with my finger. So they're often loosely bound together, the sand. And let's see where I have more sandstone. Load and shoot. Here we go. Shot. Hold on. Sandstone. I bagged everything up. Here's some yellow sandstone. And some more orangish a little bit. Here's some white. The whiter it is, probably the higher the quartz content. And so quartz is the dominant mineral in sandstone. And so when you have granite that erodes and that quartz gets lithified together to make sandstone. And then there's a sandstone variety, which I have a sample of, which is Arcos. And Arcos has this lovely rose color, sort of. It also has some largish crystals in it because it has feldspar. So you may be able to see some sparkle there from the feldspar. Let's get this. There we go. Okay. So the Arcos is this pretty rose color, and it has feldspar. So you get some nice sparkle on there. Okay. And I like to think I put the R over and just take out the K, and it's like rose sandstone. Okay, so I sort of get the word rose out of there. So it helps me remember that it's kind of a rose color. Where am I? Okay, I should have a picture of the Grand Canyon right here because the Grand Canyon has a lot of sandstone and limestone in it. Okay. So other rocks that you can get is they have silt and clay. So again, the very finest particles become silt and clay. So over here, looking at our chart, coarse rocks, coarse gravel, that would become conglomerates or breccia. Medium, the sand, becomes sandstone or perhaps the arkose. And then fine grains become silt or clay. Okay, so you've got silt and clay, and they become liquefied again to form siltstone, shale, and that happens in non-agitated water. So you've got calm water, quiet, slow-moving water. Then the particles, the fine particles, drop out, and you end up with a bank of clay along a stream bed. And a lot of the shales contain petroleum, right? Oil shales, you've heard of those. And so that's something that right now a lot of oils are coming out of Canada and in other parts of the United States. So you've heard of fracking. Fracking is one of the ways that people are forcing the oil out of the shells. And we'll be talking about that more later. Okay, so anyway, so siltstone and shale or mudstone. And let's see what I've got. So this is some mudstone. Very, very fine material. Okay, looks like mud. Okay, let me show you. This is shale. So this, you can still see the layers. Oops. Look at it from the side. Ow. Okay, so anyway. Okay, so hopefully you can see sort of how it has layers. And maybe from the other side. Okay, so you can see all these different layers here. Okay, so they're laid down. That's where the mud was laid down. Layers of mud. And then it gently fossilized. It's not very tough. Layers pop off easily. It's not a very firm material. Okay, but you can often find fossils in here that lay down in the mud. Okay, so let's go look at some of the others. Let's see, what time is it? 2:56. All right. So we've got a few more minutes. But I did want to spend some time talking about the lab. So maybe I'll save these for next time. Okay, and let's go look at the lab. So does anybody have any questions about the lab? Because we want to finish up the minerals lab. And so if you were working on the minerals lab, do you have questions about it? Were you able to identify the rest of the minerals? Go find the lab. Not there. Are you guys still there?
Yeah, we're here.
Okay, good. I know the rocks can get a little tedious here. Okay. All right. So let's go look at the lab assignment and let's see what you guys came up with. Oh, why did you guys do that? Okay, so minerals. And so looking at our minerals, we had looked at the first 9 or so. Did we do 10 of them? 11? Let's see. We did If you missed lab the other day, make sure you go back and watch the video. And by the way, of course, to see a video, you just have to go to your mailbox. Nobody ever mails me anything. And then go to your calendar. Okay, so it's not on D2L. You have to go to your Gmail. And then in your, you go to the date that you want to find the lecture, the video. And so like if you're looking for last Wednesday's video, then you would click on this. So these should be in your calendar. Well, the APS101 ones should be in your calendar. You click on those, and now you can see that there is a video which lasted till 11:04. So that was probably the lab video. Okay, so anyway, so yeah, so you'll want to go and watch that if you missed it, because we do a lot of the rocks or the minerals, and told you how to do it. Okay, so let's see. We had actually gotten, I think you guys guessed what. So let's go see. All right, so 11 was halite, right? I think we got that far at least. Or maybe not. Okay, so back to the list. Okay, so mineral 10 I told you was barite. And then, so we don't need to do that one. So mineral 11
I think 11 was halite.
Should be halite, yeah. Okay, so I forget whether we went over that or not, but so when you look at it, you see how square this crystal is?
I think we did up to 12.
We did up to 12. Okay, let's go look at 12. Okay, so so for mineral 12.
No, it was up to 14 because you gave us 14.
I gave you 14. Yeah, I gave you some of them, though, some of the later ones. Okay, I gave you dolomite. Yeah, but I'm not sure if you identified 12. Did you guys figure out what 12 was?
No.
Okay, so let's go look at it. Okay, let's go look at the varieties here, because that'll give us a big hint, hopefully. Okay, so unfortunately it's on the black background, so it's kind of hard to see the colors, but you can see there's some purple, there's some green, this is a smoky colored, and another thing is that this does show the crystal shape, and there's really only one that we looked at that was the octahedron shape, which is what this is. It's prism sort of shape of like a pyramid. And here you can see that peeking up here, like you're looking at the top of a pyramid on these crystals that otherwise look very square. But when they peek out like that, then that should tell you that this is the octahedron shape. Okay, so anyway, so that should give you a good clue about what it is. And it's very common. So so the crystal shape, showing that picture. Okay, and that may look like put that on the white. Okay, so some of my samples of it. There's that one. This one. This one. This is one I have lots of samples of because it's one of my favorites. Okay, so does anybody remember what that is? It comes in beautiful colors. See, it has the blues even. It can green, purple. What's number 12?
All right.
All right, good job. Okay, yeah. So many colors. The octahedron shape here, octo meaning 8-sided shape. The square-looking crystals here and here. So they look like they're squares, but popping out at you. And then here's the octahedron shape, where it has the four sides and four sides, like two pyramids put together. And it comes in many, many colors. So fluorite. And it's our state mineral. And there you can actually see some of the beautiful blue. Okay. So anyway, so yeah, so it's a wonderful one to collect because it's cheap, for one thing, pretty cheap. And so that's always important when you're deciding on what to collect, is something that you can afford. Okay. So a distinctive property also. And
so here's an interesting property for mineral number 12. Notice two specimens here, one showing its cleavage. Notice the color of this one is purple, and the color of this is light green. But when I turn off the lights and apply a UV light to it, minerals are fluorescent, and not only do they fluoresce, they also fluoresce in a different color. This one that was purple is now yellow. This one that was light green is now purple. That is a distinctive property of mineral 12, and where the mineral gets its name, fluorescence.
okay, so fluorite has fluorescence. And so I showed, oh, all my UV lights are dead. So I must have left them on or something. So yeah, so it fluoresces. So I've got only one light here showing vaguely that it's glowing purple. Okay, so fluoresces. So that should help you with fluorite. Okay. Anyway, and if you can get the video, then you can actually see this in action. All right, so that's a good one. Okay. Are there other ones that people were not able to identify? What did you get for the next one, for 13? Now, 13 also has distinctive properties, which we talked about. Okay, so this material is another one that I like to collect, but I don't have too much. But I collect it for its optical properties. And so you may remember the shape of the crystal, right? So when you look at it, you should see that distinctive angle that it makes. Usually it's clear, but every side has that special angle. Can you put the last two in the chat? Okay, let's see. So, yeah, I'm not going to do them all though. So, okay, so does anybody know what 13 is? Optical properties. It has birefringence, 2 images. Okay, anybody left out there? Everybody's been doing your homework? Okay. Okay, so you guys should know what 13 is.
Is it calcite?
Ah, yes, it is. Good job. Okay, so yep, 13 is calcite. Okay, and so those three things you should be able to tell apart. So they're all clear. They can't all be clear. So halite can be clear, fluorite can be clear, calcite can be clear. But you should be able to tell them apart by the shape of their crystals and by the special properties. Now, calcite also can be fluorescent. So that was something we did last time also. So calcite can glow pink, as you can see here. There it is. Okay, so I'm shining an ultraviolet light on it, and you can see how it's got pink glowing from it. The other one, a little bit pink too. Okay, so it also has fluorescent properties. But those are three things that are all can be clear and that you should be able to recognize. Okay, all right, let's see, 309. Okay, so does anybody have any other ones that they've been working on and they aren't sure what they are? You want to get these finished up because we'll have to start doing the rocks soon. And I told you 14 was dolomite, so you should have that one.
Can you go over 18?
18, sure, let's go look at that. Okay. Now this one we didn't talk much about its crystal shape, so this probably won't help much. Because usually it's more of an amorphous looking set without much crystal. Come on. Oh no, did I? That doesn't seem to help much. Okay, seems to be a blank there. Okay, let's go down to varieties. Okay, so usually it's a dark rock, as you can see, not very distinctive looking. Mostly how you tell the difference on this one is special properties. Now there are 4 dark metallic looking, slightly metallic looking rocks in your set usually. So you've got galena, you've got iron pyrite, you've got hematite and magnetite. So those 4 are hard to tell apart because they're all black rocks basically. Okay, but some of them are silvery. Okay, so galena, magnetite, hematite, and what did I say? Pyrite. So it's one of those. And to be hematite. Okay, hematite. So the thing is to know those, galena has that beautiful shine to it and really silvery looking often, very square crystals. Pyrite, iron pyrite is that slightly goldish color. So this does not look like iron pyrite. I mean, this is yellowish, but it's not good like iron pyrite. It doesn't look like those little square crystals. Hematite can sparkle. Okay, it's what's called specular. So you might think maybe this is hematite. Hematite also can show red. It's called hematite because of hemoglobin, blood. And so it can often have that, because it has iron in it, it often shows a sort of rustiness to it. But this one is a little tricky because it's like, what is this stuff? But it does show you an interesting crystal here. So that looks like an octahedron. And so you might look on your chart. And of course, the other things you would want to get from this is the streak and the hardness and the distinctive property. And this property is so distinctive that it probably will give it away. Okay, so. Okay, but unfortunately you need the video to tell what's going on there. So what is going on there? So if I download the video, I might be able to get it to show. But hopefully you can get that in your working for you. But the main thing that you're going to get from that is that a magnet will stick to it. And so that should give you the clue as to which one of these minerals it is. Okay, so did that help?
Yeah, it did. Thank you.
Okay, all right. Okay, so look at the streak, look at the hardness. Those should give you the right area, and then that distinctive property. Okay. All right, was there another one someone had a question on? I wonder how many students I have left. Okay, well, I guess class is over, so see you next time. Okay, so see you on Wednesday.
Thank you.
Thank you.
Bye.
Thank you. Okay, so and work on your lab. So if you've got questions, I can help you with this. Okay. And if anybody has questions now, they want to stick around, they can do that too.
Bye. Thank you.
Okay, bye.
Thank you.
No, people are leaving that. So look at here.
I had a question about the slides you have. Are those on D2L?
The slides that are part of the lab.
Just the slides you were going through all today.
Oh yeah, all the slides are on there. Is this Andy?
No, this is Elin.
Elin. Okay, all right. So
I found the Bowens, RS, and igneous rocks, like those, the charts and stuff.
Mhm.
Where are the slides?
Go back to table of contents. Okay, so in the content, and go down to where it says Morrow's PowerPoints.
Oh,
So right
okay, that
now,
makes sense.
Dr. Dave's PowerPoints are still in the chapters, but if you go down, Morrow PowerPoints, and that has all these PowerPoints.
Okay, so which one? So how do you know which ones are Dr. Dave's and which ones are yours?
Well, all these are mine. So
Oh, okay,
Morrow
okay.
PowerPoint. And
Okay, perfect.
Dr. Dave's are still in the lecture module, so I need to rip them out. So I think
All
yours
right,
are still in
perfect.
there. So yeah.
And then in regards to the lab, just once we have all 18 of them, do we just use those for when we take the lab quiz?
Yes, definitely. You definitely need to.
Okay.
That's what the quiz will
Right.
refer
Okay.
to.
I just
Okay.
want to make sure I wasn't missing anything.
And you do get 2 chances, so if you take the quiz and say, "Oh, this is weird," you can always ask me a question too or something. If there's something
Awesome.
that doesn't make sense. Okay.
All right. Thank you very much.
Okay, sure. See ya. Let's see who's left. Patrick, Sean, Tatiana, Taylor, do you have questions?
I have a quick question
Yeah, go ahead.
regarding the I guess how to watch the lectures since you're recording everything. Where do I go for that?
Okay, so I'm going to stop this recording. Thanks for reminding me.